So part C then, the point B has position vector 5, minus 1, 1. Show that B lies on L1. And find the shortest distance from B to the line L2, giving your answer to 3 significant figures. So B is 5, minus 1, 1. So let's bear that in mind then. We've got to show that B, here it is on L1 first of all. So let's have a go at that then. So part C, I'm going to paste in the line from above, the L1 line. So I've got it here. And then we need to put in the vector B. So the point B, OB, is equal to, now what was it? Let's just get it from the question. 5i minus j plus k. 5i minus j plus k. We need to show this lies on L1. So for it to lie on this line, then the 5, when does 6 minus lambda equals 5? Lambda equals 6 minus 1. If I put 1 there, I'll get 5, won't it? So if we try lambda equals 1 then, the r vector is equal to 6 minus 1, which is 5i, minus 3 plus 2 is plus. Minus 3 plus 2 is minus 1. So that's minus j. And then minus 2 plus 3. 3 minus 2 is 1. So r equals that. Which is the point B, isn't it? The point OB. So B is on L1. So that's part C. Now let's have a look at part D. We've got our 2 lines here. Here's the point B on L1 then. Let's put it in here in the picture. So basically, find the shortest distance from B to L2 to 3 significant figures. So if we drop a perpendicular like so, we'll have a triangle here, won't we? Here's A, here's B, here's the distance here from the perpendicular height from the point to the line, and we've got this side of the triangle here. So we've got a triangle, AB, so let's draw it then. D, here. What have we got then? We've got AB, we've got this distance and this distance. This is a right angled triangle. This was the angle theta dash, the acute angle between the 2 lines. Here's A, here's B. So the vector, the distance AB then. Well, let's get the vector first. The AB vector from A to B. Now B is 5 minus j plus k. So it's 5i minus j plus k. So that vector is B. Take away the vector A, OA. So A is 337. So 3i plus 3j plus 7k. So we can write it like that if we wished. If we wish. So 5 minus 3 is 2i. Minus j minus 3j is minus 4j. And then k minus 7k is minus 6k. So AB then, the modulus of the size of the triangle, of the longest side, is the square root of 2 squared plus 4 squared plus the 6 squared, isn't it? So 36 plus 4 is 40 plus 16 is 56. So it's the square root of 56. So D, so sine of this angle, so here, so sine of theta dash then is equal to the opposite, D, over this hypotenuse, which is root 56. And this tells us now what D equals. Square root of 56 times the sine of theta dashed. And we worked out theta dashed above in the previous section. It was 69.075. 69.075, nice and accurate. Put that in the calculator then. We need to 3 significant figures. So we're in degrees mode. So it's root 56 outside the square root times the sine of 69.075. Close that bracket. Equals. Now to 3 significant figures is 6.99, isn't it? units, and that's the distance between the point B and the line L2, the shortest distance.